In this video, we're going to talk about multiplying and dividing rational expressions. So let's start with this. To multiply rational expressions, we're going to treat them just like we would fractions. So if you have P over Q times R over S, you're going to multiply across the top, and you're going to multiply across the bottom to get PR over QS. Hopefully pretty simple. So let's take a look at an example here. So let's say we want to simplify 2x over x squared minus 7x plus 12 by x squared minus 9 over 6x squared. So what we're going to do is we're going to simplify this a little bit before we get too far, just to make it a little easier to do that multiply across. So in this case, I want to factor each piece that is factorable, and then I'm going to multiply across. So for example, x squared minus 9 is a difference of squares. So I'm going to factor into x minus 3 times x plus 3. And x squared minus 7x plus 12 is a trinomial that is factorable. The two numbers that multiply to 12 but add to negative 7 are negative 3 and negative 4. So that's why it becomes x minus 3, x minus 4 there. So now that I've done my factoring, I'm going to go ahead and multiply my numerators and multiply my denominators. So I now have really 2x times x minus 3 times x plus 3 over x minus 3 times x minus 4. And then since it's times 6x squared, I will pull that to the front because it's not a binomial. So since it's only one part of a term, then it will be much easier to work with if it's in the front. So once I've set that up, I want to simplify. So notice that 6 could be broken up into 2 times 3, and x squared could be broken up into x times x. So that's how I have 2 times 3 times x here, okay? But once I have split that up, I can now cancel out things that are the same in the numerator and the denominator. So I cross out my 2's, I cross out my x's, I have an x minus 3 that I can cross out on top and bottom. And so then I can just rewrite what is left over. Okay, so I have x plus 3 left over in the numerator. I have 3x and x minus 4 left in the denominator. So let's try another one. Taking a look at this, I want to multiply it. So again, my first step is to factor. So I'm going to factor out both the numerator and the denominator, and I'm going to multiply it across. So factoring out 3a squared minus 8a minus 3 comes out to be this 3a plus 1 times a minus 3 using the AC method. And a squared plus 10a plus 25 is a plus 5 times a plus 5. And then a squared minus 25 is going to be difference of squares. So it becomes a minus 5a plus 5. And 3a squared minus 14a minus 5, again with the AC method, is going to be 3a plus 1 times a minus 5. So now that I've literally done both of steps 1 and 2 in a single step, factored and multiplied across, I'm going to be able to simplify this. So notice that 3a plus 1 happens here and here. A plus 5 happens here and here. All right. And notice that I'm only crossing out one of the a plus 5s from the numerator because I only have one a plus 5 in the denominator. Now, whatever is left over is going to be a minus 3 times a plus 5 over a minus 5 times a minus 5. Now, we do want to rewrite a minus 5 times a minus 5 as a minus 5 squared because that is simpler. Since it's repeated, we'll write it with that exponent. Now, multiplying over, right? Well, sort of, because the next thing we're going to do is dividing. And when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So dividing by r over s is the same thing as multiplying by s over r. So even when we're doing division, we're really doing multiplication, okay? Now, fractions, again, are going to be treated the same way, or rational expressions are treated the same way as fractions. So when we take a look at something like this, p cubed plus q cubed over 2p squared plus 2p cubed, 2pq, sorry, plus 2q squared, divided by p squared minus q squared over 6, what we're really going to do is we're going to change this to a multiplication problem. So some people may have heard this as keep, change, flip. You'll keep the first fraction, change to multiplication, and flip the second fraction. Again, that's the same thing as saying dividing by a fraction is the same as multiplying by its reciprocal. So in this case, we're flipping p squared minus q squared over 6 when we change it to multiplication. All right, and that's where this comes in. So now it's just a multiplication problem. We can do all the same things we've done before, which means we're going to factor. Notice that p cubed plus q cubed is a sum of cubes. So you're going to use that SOAP principle, same, opposite, always positive. All right, 2p squared plus 2p cubed plus 2q squared is going to have a greatest common factor of 2. So you're going to factor that out, okay? 6, I'm going to go ahead and write as 2 times 3. And p squared minus q squared is a difference of squares. So I can factor that to be p minus q, p plus q. So now I can multiply across. And now that everything's in one fraction, I can simplify that fraction. I'm going to be able to cross out anything that is common. So I'm going to start with this 2 on the bottom because it's easy for me to forget it if I don't pay attention to it right away. And I can also get rid of that p plus q that's on top and bottom. Now I'll bring that 3 out front because I do like the single numbers, the coefficients, the constants, to be in the front. It makes it much easier to read. All right. And then I can't simplify this anymore, so I'm done. Now, what about this one? It looks completely different, right? It's got way too much fraction-y fraction in here, right? Well, don't worry. Well, it's actually easier than it looks because this fraction bar right here in the middle is for the big fraction. So we really have this divided by this. So big fraction bar, you just think of like division. So rewrite it with the division sign. Top fraction divided by the bottom fraction. Now we're going to rewrite it with multiplication in mind. So we're going to change that division to a times, and we're going to flip the second fraction. Now that we've done that, we're going to treat it just like all the multiplication problems we've done so far. So that means we need to factor, okay? When we factor and then we multiply the numerators and denominators, it's going to come out to this. And again, we can cancel out any common factors. In this case, 2x minus 1, x minus 2, and x minus 3. So all that's left is 3x minus 2 over 4. So this actually simplifies quite a bit. And that is how you multiply and divide rational expressions.